The alternating series test part 2, the alternating series error. Why does an alternating series converge if the absolute value of the terms decreases to 0? So without loss of generality, let's look at the series -1 to the n plus 1 of a sub n, which would give us a sub 1 minus a sub 2 plus a sub 3 minus etc. And let's assume a sub 1 is positive. On the number line, I want to put the sequence of partial sums. Okay, what does that mean? Well, if a sub 1 is positive, a sub 1 will land right about there or somewhere on the number line. And we could say that the sum of the first 1 terms is a sub 1. Well, the sum of the first 2 terms is a sub 1 minus a sub 2. Now, where would that land on the number line? Well, I'm not going to put it on the number line because it'll get really messy. So instead, I'm going to draw it right below just so we can see what's happening. So my claim is that the sum of the first 2 terms would land right about there, where this distance is a sub 2. Now, why would it land here, for example? Why couldn't it end up over here? That is, why could s sub 2 not be bigger than a sub 1? Well, that's of course because I have positive terms. That is, a1, a2, a3 are positive, but I did a sub 1 minus a sub 2. So I must have a decreasing value in my sum. Furthermore, I know that the value can't be out here. That is, s sub 2 can't be less than 0 because the value of my terms are decreasing. So how about s sub 3? The sum of the first 3 terms would be a1 minus a2 plus a3. So I know that we're going back in the original direction. So if I draw something like this, the sum of the first 3 terms will land right about there, where this distance is a sub 3. And I could continue on doing this. Sum of the first 4 terms, sum of the first 5 terms, etc., etc., etc. And since I have terms that are going back and forth and decreasing to 0, I know that the sum out to infinity must converge somewhere. But there's another very, very important result that I see from this picture. And this result has to do with the error when approximating my infinite sum, that is s sub infinity, with a partial sum, s sub n. Writing one more for us so we can see it here. So what if I wanted to approximate the infinite sum with just the first term? What is the maximum possible error when I use this approximation. Well, if my guess is right here, and let me change colors for us. If my guess is here, I know that I am no farther away than that length. So my guess, that is the error or remainder used in the first term, is no more than the distance a sub 2. But what if I want to approximate the infinite sum with the first two terms? What is the biggest possible error? So if my guess is right here, what's the farthest I could possibly be away from the answer? And the answer is, I couldn't be any more than this distance away. So the error or remainder using the first two terms is no more than the distance a sub 3. In general, we see that the remainder or error using the first n terms is no more than the absolute value of the first left off term. And this is called the alternating series error. This is much, much easier than the Lagrange or Taylor series error. So I want to do one quick example with you and leave other examples for the next video. So let's do this. Using the fifth degree Maclaurin series, or the Maclaurin polynomial approximation, I'll just call it the fifth degree Maclaurin. And we're going to do this to approximate the sine of 1 what is the biggest error we could possibly have? Well, let's write out the Maclaurin series. Let me leave that there so we can see that. Let's write out the Maclaurin series for sine of x. Well, sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, etc. Using the fifth degree Maclaurin, then, sine of 1 is approximately 1 minus 1 over 3 factorial plus 1 over 5 factorial. Well, what is the biggest possible error with this approximation? Well, I know that my remainder is going to be less than or equal to the absolute value of the first left-off term. Well, there's my first left-off term, so 1, or 1 to the 7th, over 7 factorial. So using the fifth degree Maclaurin to approximate sine of 1, I know that I am no more than about 0.0002 away from the actual value.